So welcome to New York and to Mastering the Cloud Native Wave, Security Resilience in Modern Systems. Andy and I will introduce ourselves momentarily. For now, we would like to thank Finos and the amazing staff behind Finos for organizing another amazing event here in New York and giving us an excuse to fly from London to New York once again. Sir?
Right, thank you very much. Hi, I'm Andy from ControlPlane. We are cloud native security and professional services, and I'm proud to be involved with some illustrious organizations over the last few years. We've done work with Open UK, we work with open source foundations, and we work with non-profits as well to advance the good news of open source into financial services. We do government advisory and various other associated initiatives. And
as I said, I'm Francesco, Head of Technical Solutions at ControlPlane. I started my career in the European government. I wasted my youth in data centers, very dusty ones, not exactly a cloud-first organization back in 2010. And then I moved to Inmarsat, a global satellite mobile provider. I spent 7 years trying to prevent threat actors from blowing up spacecrafts. They tend to be very expensive. Yeah, so that's what I did. And then I joined ControlPlane. I didn't want to see a data center again in my life. So I joined ControlPlane when I'm Head of Technical Solutions. As I said, hey, welcome. Basically, what I do in the company is I work with Andy, our CEO, to come up with, to maintain the firm at the cutting edge of our industry in cloud native, both from a services and a product standpoint. ControlPlane, London headquartered, fully bootstrapped, founded in 2017 by this gentleman. We basically provide security consultancy to regulated industries, FSIs in particular. We help them in their cloud-native transformations. We threat model anything. If it runs on a computer, we are able to threat model it and harden it. More recently, we focused on CI/CD, AI, MLOps systems, of course, and then the software supply chain. We also build DevSecOps. And I say build not because it's only in terms of technology, but also in terms of culture. So we basically bring them to a modern, agile-based paradigm. And then, of course, if we build it, we want to make sure that these organizations they have enough visibility, so we fill the gap between cloud-native platforms and security operations centers. We assure open source. We have an enterprise-grade distribution of Flux CD. And then we run offensive and defensive security engagements. Very well. What are we going to talk about today? Well, first of all, we'll start from the good stuff about cloud native. And apologies if this will sound familiar. My CTO, Ash Ward, said, don't assume everyone is on the same page. Put the slides, and of course, he's the boss. So I said, yes, of course I will. And then we'll move to the challenges around cloud native. And why? Because we want to present you with a cloud-native way of overcoming these challenges through our approach, which is detect, correct, and protect. We'll hear this many times throughout the presentation. So we extend IT security traditional disciplines like threat modeling, engineering, and security operations to cloud-native infrastructure. And then we'll draw some conclusions. So again, apologies, boring slide on the way. But just to make sure we are all on the same page, let's talk about real quick what the benefits of cloud native are. Very accessible. You effectively just need to use your credit card, and you can spin up infrastructure. By the way, I assume you all know what cloud native stands for. It's basically anything designed for cloud, to run in cloud. And I'm not talking about public cloud. It can be private cloud as well. So just in the credit card, and I assume your CFO knows very well about that. Scalability and elasticity can scale up and down based on need and demand. Automation, we'll talk about automation a lot. Basically allows you to seamlessly provision and remediate, reducing thus manual operations. And then interoperability, again, is entirely API-driven, so you can get all these entities to talk together using open standards. And built-in resilience and fault tolerance. So it's built-in high availability and recovery. More good stuff. So cloud native is very well suited for a few things. Microservices-based architectures, decoupled services that can talk again together thanks to the interoperability, all API-driven. And of course, the declarative paradigm and reconciliation. I won't explain what this is because we have a slide just after this only about that. And then self-service infrastructure and services. So thanks to Cloud Native, you empower teams to self-provision what they need. And hopefully, if you do things right, whatever they provision is compliant and secure by default and by design. Plus observability, security observability, operational observability. Cloud Native, thanks to, again, to the API-driven model, allows you to achieve that. Plus summary. It's easier than ever to build secure and compliant by design and by default infrastructure patterns. Speaking of declarative paradigm and reconciliation, I was wondering if you could enlighten us
Right,
what that
thank
is.
you very much. Very pleased to. So, with all these capabilities and features, organizations can perform what is known as inversion of control. Instead of having to push the state to the things that we're looking to configure, we can remove that credential, we can remove the human element, and instead we can invert the control. So we'll look at how this is done with the GitOps pattern. This is fundamental to not only how declarative infrastructure and deployments work, but also GitOps is one of the underpinnings of the transformation that Kelsey started talking about with Puppet, which is configuration management. We're looking to fix configuration drift, but it's a different form of configuration management because it's a much faster reconciliation loop, and it sits at a slightly different, more transitive level that we'll talk about as well. So what does this mean? It means that your CI doesn't need to have credentials to push to production. It pushes somewhere in the middle where we're storing the configuration, and that is then pulled in. This trusted external source can be Git, it can be an OCI registry. It's essentially just a bunch of bits. They're text files, maybe they're structured, but there's no special source to this. So all we have to do is to state our intention, and then some dark magic like Flux CD, which is Flux Continuous Delivery, Argo CD is the same idea. They will reconcile this projected state into the actual, so desired, expected into the actual state of not just a cluster, but infrastructure, policy as code, security as code. Everything is defined as bits and bytes, and then we destroy ClickOps. There is no more concept of going into the terminal, or the console rather, and changing state. So, as a good friend of mine, Tabby Sable, once said, we write our hopes and dreams in declarative form and pray to the machines and hope that they deign to enact the vision of the future that we hope for. And it's not always the case, but generally, this means, what can we do with this pattern? Well, we can provision repeatable infrastructure. So instead of going and building out the same infrastructure 10 times across an organization, this allows us to do it once and to reuse that pattern and to know that we're getting the same outputs. It also allows us to deploy applications. We can have complex application deployments that have structured dependencies that require certain triggers to fire before other pieces. Obviously, anything stateful, queues and data stores are nightmarish. This gives us a repeatable tested pattern that obviates any human control. We can validate and test those components because we're deploying things that can then provide their own tests. So you deploy a load of infrastructure, you deploy a VM that runs the tests to deploy that infrastructure, and then we can put completely, not necessarily air-gapped, but offline, so away from the public internet, or actually fully air-gapped systems that self-test from the inside, and then we pull that back again because we're not having to open any new network routes. We've got everything through the same deployment structure. And then finally, in the event of any form of failure, automatic rollback. This is integrated with everything we know about feature flagging, about canary releases, about blue-green. There's multiple different continuous delivery mechanisms, all supported by this pattern. So the beauty of this system is in the event of accident or malice, which is what we see here with app 1, any direct modifications to the underlying resource that are managed in this manner are automatically rolled back. There is no possibility of configuration drift because the reconciliation loop is very, very tight. This effectively fixes states and configuration drift. It does require an immutable mindset. It's a different organizational pattern, but the repeatability and the production guarantees that you get with this are far superior to anything that we've done before. Again, sort of going back to the puppet play, thank you very much. It's a form of sorcery, and it's the same thing, but in a much tighter, much less, as they say, much less distributed. But Puppet did not have the benefit of a centralized control plane, be that necessarily AWS or a cloud provider or Kubernetes. Any of these paradigms that abstract away programmatic infrastructure are different to using Puppet to deploy onto 10,000 servers in a data center. Now, we have OpenStack, maybe it's slightly different, but this is the cloud-native version of the same configuration management. So this is an advanced platform. This is also what the Finos Common Cloud Controls project enables. So come and talk to us later, or go and talk to Eddie Knight, who's deeply involved with this. Common Cloud Controls is repeatable cloud infrastructure, and it can be deployed under this mechanism without configuration drift. It's like running Terraform 10 times a second. This means this is end-to-end secure cloud adoption from pre-delivery through to infrastructure with self-validation and testing, baselines against threat models, which contemplate whatever security standards your specific use case requires, and reflects changing threats from the wider internet, because the Common Cloud Controls is contributed to by multiple different banks, and therefore the rising tide lifts all boats. Open source collaboration for infrastructure and code.
Now, does that sound too good to be true? Yes, it does, because unfortunately there are some challenges around cloud native. Hello, hey Win, how's it going? All good here. So what are the challenges around cloud native? And I'll skim through because in the interest of time. So in terms of, it's quite new in terms of enterprise technology life cycle, and ever-changing. So every day, hyperscalers, they introduce new features, and teams, they have to keep up, especially incident responders. Very complex. It can lead to technical debt because of uncontrolled proliferation. Cost, again, your CFO with his credit card or her credit card in the account will know. And then there are many shared responsibility model permutations. This is also true for internal teams. It's very hard overall to come up with a sustainable target operating model. I'll skip this slide. It was just to present that just if you start using Kubernetes you deploy a cluster, suddenly you have 4 more layers that you have to secure and configure properly. The orchestration, runtime, the networking, and the security layer. Again, overall, what's happening here? We are witnessing that organizations are facing 2 main challenges. One, it's very hard to keep a cohesive risk management approach. And as a result, the gap between technical teams and decision makers is widening, especially around strategic business roadmap and technology adoption roadmap, which should unlock and enable that business mission, translating into a widening gap between existential business risks and technical risks. Monsieur?
And this is at the heart of the points of the rest of the presentation here.
Speed up.
The technical business risk. What does that actually mean unless the stakeholders, the individuals with the existential concerns about the lifetime, the lifeblood, the competitiveness, the feature delivery of the business have something quantifiable? So this is how we go about, as a small organization across the Five Eyes territories across the world, this is how we go about demonstrating value to our stakeholders and successfully instigating change in some of the largest organizations in the world. 3-stage process. What is the state of things? How do we get there to a point that we know we've de-risked to the agreed level? And how do we stay there once we're there? So it's worth looking at the Finos report just now. ControlPlane specializes in the top of this list, essentially. We do not do data, and we don't do blockchain or virtual reality.
Yet.
But if it is to do with what is ultimately DevOps, DevSecOps is just security features on top of very good DevOps, because you can move quickly, you have an embedded champion in the team. This is what we do. Kind, collaborative, passionate, and boutique. So into the corrective or detective maneuvers, actually. Let's start off with threat modeling. We can't secure everything, so how do we identify what is most important to limit blast radius, to understand if we need to get observation and detection? You know, we can put in preventative controls, we can put in detective controls, we can put in automatically remediating controls, but the computational complexity and management of each of those comes at some cost to the business. We do this via threat modeling. So the discipline itself, this is a catastrophization exercise. What is the very worst that could happen? And for my sins working in government, it was generally what happens if the data center is a smoking hole in the ground. However that happens, what happens next? And that mindset puts a different lens on what is otherwise just turning up for work every day, blowing dust off server racks. So we take those worst possible outcomes and we work backwards. What would happen if we had no root of trust in our organization? What would happen if we had no failover and all of our data meant that we couldn't trade for the next X period of time? And then we run forward from known previous areas of risk. Well, we know that we keep on getting attacked by this APT, by this nation state, and we know that they've attacked Swift. How do we bridge that into our infrastructure and see what about clearing transactions? And it's maybe a slightly specialist or slightly different from many of the trading use cases here. That information goes into attack trees. This gives us a quantifiable view, such as this, in order to understand, well, how do we trace this attack through? And the important thing here is to make sure that we can unlock value for the stakeholders and unlock funding for remediation. There's no point doing this initial phase of the exercise if the senior stakeholders say, right, well, you just got some techies in to say the world's going to burn. We knew that was going to happen anyway. So we start with the system. We take the variety of threat actors. That could be script kiddies, it could be nation-state aligned APTs, organized crime. This is how Russia operates. It could be universities sat next to Ministry of State buildings. That's how China operates. And it could just be nation states running rogue with sort of less visibility. We take the threat objects, we build our attack trees, and we trace through the technical risk of these things occurring, and we anchor it back, ultimately, to this remediation roadmap. Again, this is where we get back to the existential risk, because how long can we survive without a certain database or a particular region? What happens if US East 1 goes down, where most of the world's authentication bounces through? Do we have a backup plan? And obviously, somebody at some point will balance that risk and say, well, we can put it onto insurance, or we just shut down. Whatever it looks like, there has to be some form of answer.
Shall we do it for a system we recently threat modeled?
That's an excellent idea, Francesco.
AI, MLOps, of course.
So we've been working in open source in the community as well as behind closed doors to work with AI and ML systems. So we're not using security and AI tooling. So we're not adding AI to Nmap or whatever that would look like. We're going the other way around. If someone is training a data pipeline and the outcome of that is a model, well, banks have been doing that for years. Statistical machine learning, linear regression, we're used to these things. But LLMs open the attack surface because suddenly the entire bank gets access to the same thing. So for the sake of this presentation, we've cherry-picked a few key points here. And whether the industry moves fully towards RAG on other people's models, we're actually going to train and attempt to train foundational models, slightly different question. We're seeing chain of thought thing or chain of reason things going a little bit differently at the moment. But the point here, what's the worst that could happen? Well, some of those things, manipulation of training data. This model doesn't do what you think it does, and you've got no way of detecting that backdoor at production. There are a lot of papers on this right now. Second of all, perhaps messing with the training and tuning parameters. So the data that's going in is good in some way, but we've tuned it in a way that displays bias towards a particular group. And we don't know about that because we don't run the large-scale data quantification tests that you might expect. And or rogue model in production. Did we pin the version of the third-party API which has an LLM behind it? Or is it like a tag, like a pointer? We're just using latest the whole time. So the fundamental differences in reasoning capability between a GPT 3.5 or a Turbo or a 4 and a 4 Omega, do they match the benchmarks that we expect if we're making foundational decisions based on foundational models? perhaps through absence of version pinning, supply chain, lack of signature validation, and a host of other threats that we've built out in Finos, of course. So we've been working in the AI readiness group, and all this work is now ready to be open sourced. We've contributed a load of threats back into that group. This is significantly, how does a bank use an external LLM to write one email? Reductionist, most simple case possible, and the answer involves treacle, rowing boats, and various wailings and gnashings of teeth. I'll talk about this tomorrow at, I guess, approximately the same time.
No, remember.
At some point
The PM.
tomorrow in detail, along with an AI red team framework that we've built to validate these controls. So the high-level controls to mitigate those threats, I mean, in this case, and for a sort of formative threat modeling example, this would be, well, we make sure we've got read-only data mounts. So ideally, the supply chain of that data is sacrosanct until we get to it, and then if someone gets into our production systems, they're going to have to do some crazy things to get the read-only data and sort of tamper with it in memory as it's moving around. What about the training and tuning? Well, version control parameters, again, talking about this GitOps inversion of control, we're pulling those from a well-known place. There is no opportunity for someone to get into a build server and push them. They have to tamper with Git, which is a system of record, which is signed, and we can rely on cryptographic hash functions to be sure that that's actually the case. And finally, what about at production, at runtime? Well, runtime integrity, there's multiple different layers from confidential computing all the way through to signing the binaries that we're running and some of the things that came through in the keynote. This is a compressed version. There's plenty more, and it's now all open source and baselined against things like the OWASP LLM Top 10, MITRE TTPs for cloud native, for AI, and various other good stuff.
So if we go back real quick here, I hope you noticed, I'll tell you now if you didn't, the whole stack was built on cloud-native technologies, Kubernetes, and then Kubeflow implementing TensorFlow. So the purpose of enumerating threats and then to select high-level controls is to then, because we are in the cloud-native space, to choose the right cloud-native controls leveraging the 4 tenets of cloud native, aka automation, interoperability, declarative and reconciliation paradigm, everything as code. Because, well, what's the point of having these controls if you don't know how to implement them properly in cloud native, trying to make your life as easy as possible? Well, that's what we do. Are you going to connect to the individual systems and configure things different way? Of course not. You ask your Kubernetes clusters not to ever allow data volumes to be mounted read-write. That's how you implement the controller in the cloud-native space. You will implement it differently if the stack was another one. Now, the point being, you do it declaratively, and the system magically will enforce everywhere. Same goes for the version control parameters. You can ask, hey, FluxCD, continuous delivery tool, monitor this repository and propagate changes. So again, data scientists will not have access to snippets of code everywhere. They will have access to a single repository where all the Jupyter books are stored, and then upon committing a new change, FluxCD will basically propagate those using, they will build images from those, but then will execute on the cluster. Again, humans don't need access to the actual platform. As well as, to guarantee runtime integrity, we don't configure things manually. We tell Kubernetes, please do not ever allow models which are not signed to run. So we build the model, we train the model, we build the model, we sign the model, and then we send it into execution, into production, and Kubernetes will only allow models signed by a specific party to actually run. Now we detected issues, we are correcting issues, let's protect the overall system, again, through cloud-native security operations, extending security operations to the cloud-native space. What are the challenges here? Well, again, big skill gaps, too many new features. Incident responders, they struggle to keep up. It's very hard to get observability right. Again, too many layers. And then you get the poor forensic guy who used to go and collect the laptop and take a forensic image and store the image. They suddenly have to deal with volatility on Kubernetes clusters at scale, leading to custom detection and response requirements, aka very tailored response procedures. Once again, let's look at our reference architecture. 3 threats: threat of data being manipulated, parameters being tampered, and a rogue model being loaded. What should the security operations team do? well, not run around like headless chickens. They should, again, leveraging the 4 tenets, come up with something smarter, aka, in case there is a data manipulation, they can respond real quick by telling, hey, Kubernetes, give me all the workloads that access a specific volume in the period of when the alleged breach happened. Or, hey, FluxCD, please roll back the entire system to a known good state. I assume this is a compromise system. Roll back to the previous version. As well as, Kubernetes. Let's take a forensic image and block network access, isolate resources, done declaratively, and allowing the system to do it for itself. As we head to the conclusion, Andy, would you like to?
Perfect timing, synchronized with next door's thunderous applause.
Yeah, we are almost late.
So what we have here is, as with so many other technological evolutions, you have a load of people turn up and say, throw everything out because we've got a whole new way of doing it and we're the people to use because the old people are calcified and glacial. It is not the case with security. The rules are the same. Don't run things that other people tell you. Don't curl to bash from the internet. Sign everything that you do. Make sure you integrate with your friendly local neighborhood security operations team. Cloud native breaks some existing paradigms, like there's no link to IP, so all of a sudden identity changes into a layer 7 concern. But broadly, we are still in the same market as we were. We're still running everything on bits of melted rock, and it's a miracle that anything works anyway. So first of all, we have to extend these security disciplines. Everything is just a conversation, breaking down the silos, and making sure that we behave to our security teams as we would like them to behave towards us. Cohesive risk frameworks. These exist. Your organization probably has enough of them to burn a small forest somewhere that needs the wood. But nevertheless, extending these out to include, well, what existential risk, when you consider that data center being a hole in the ground, is related to a lack of cloud access, for example, or related to a lack of physical access to somewhere that's locked with a different type of key. We need to take advantage of the cloud-native capabilities, and we may be able to turn off controls that exist from the old world because we have new ways of doing things. A good example of that is, well, do we lock everything down by IP again? Well, Zero Trust actually defines that we want to get metadata about the connections and instead use a more complex set of heuristics to identify, do we trust this? Is it on the sliding scale of risk or the concertina of risk? Is it somewhere that we trust right now, midday Wednesday, well, I suppose, let's say midday Monday? Would we trust it last thing on Saturday night? And that's a very simple model. You can expand that a lot more widely. Cloud-native capabilities, we've spoken about the portability, the different robustness options that we have. Anchoring these is important in order to take advantage of these modern patterns. And finally, that technology roadmap. We quantify risk, we build out the solutions on the back of it, and then we make sure it's executed in line with the high-quality standards that our organization already expects. And with that cue, thank you very much for your attention.
Yeah, well, Andy and I always overrun on stage, so we don't have time for questions, but we are at booth 10 right next door if you want to join and have a conversation about these topics or anything cloud native.
Thank you very much.
Thank you.
Thank you.